Hey everyone, welcome back. Today we're
Hi.
doing a deep dive into radon.
Radon.
You sent over some really interesting sources. We have a scientific overview.
Okay.
We have a really in-depth Wikipedia entry, and then something about like radon's discovery.
Wow.
So we're going to synthesize all this information and hopefully help you become a radon aficionado.
Sounds good.
I think everyone kind of knows about radon, but they think it's like a basement problem, right?
Yeah, it's definitely known for being a basement problem, but there's a lot more to it.
Right.
I think to start, we have to answer the basic question, what is radon?
Okay, what is it?
So radon is a chemical element.
Okay.
You can find it on the periodic table.
Okay.
It's element number 86.
Oh, wow.
And it's represented by the symbol Rn. Now, what makes radon unique is that it's a noble gas, meaning it's not very reactive, and it's naturally radioactive.
Oh, okay. So it's a gas and it's radioactive.
Yes.
That sounds a little scary.
Yeah, I mean, the radioactivity is where things get interesting.
Right.
It's actually a decay product of radium,
Mm-hmm.
which itself comes from uranium. So it's
Mhm.
constantly being formed as these elements decay.
Okay.
And uranium and thorium, those are the elements that radium and radon come from. They're present in rocks and soil pretty much everywhere.
So it's forming everywhere. So like right now under our feet, radon is forming.
To a degree, yes.
Okay.
I mean, the good news is that outdoors, it's usually at very low levels because it's diluted in the open air.
Okay.
But when you get into enclosed spaces, that's where things can get a bit dicey.
Right. Yeah.
It can seep into buildings from the ground below,
Right.
especially basements. And you can even find it in well water.
Right.
So it's really, I think that's where the basement problem comes from.
Yeah, that makes sense. Okay. So you sent over these sources and you mentioned this thing called the Watrez incident. Can you tell me a little bit about that?
Yes, the Watches incident. That was actually a pivotal moment in the understanding of radon risks. It involved a guy named Stanley Watrous.
Okay.
He was a worker at a nuclear power plant
Okay.
in Pennsylvania,
Mm-hmm.
and he kept setting off the radiation alarms at work.
A nuclear power
At
plant.
a nuclear power plant. But here's the thing.
Okay.
The plant wasn't even operational yet.
What?
Yeah, so they were really confused. Why is this guy setting off the alarms?
Right.
And so they finally traced the source of the contamination back to his house.
Oh, so he was bringing something home from work, like on his clothes or something.
Not at all. It turned out that his basement had incredibly high radon levels,
Oh, wow.
like exceeding 100,000 becquerels per cubic meter.
Okay. 100,000. I have no idea what that means.
I mean, to give you some context, the EPA recommends taking action to reduce radon starting at 74 becquerels per cubic meter.
Oh, wow.
So his house was like off the charts.
That's great. So, I mean, it's just this invisible gas that like could be a real threat.
Yeah.
Okay, so you mentioned that it comes from uranium decay. Did people ever think that radon was like good for you?
Believe it or not, yes. Early in the 20th century, people actually used it in medical treatments.
What?
Yeah, they would take radon baths for things like arthritis.
Radon baths.
Radon baths. And it was even used in some early forms of radiotherapy.
That's crazy. What was the thinking behind that? Like, why would they think that?
Well, back then they were just starting to explore, the therapeutic potential of radiation.
Okay.
And they thought that low doses of radiation from radon could actually have some beneficial effects.
Okay.
But as research progressed, it became clear that any perceived benefits were far outweighed by the risks of radon exposure.
Right.
So yeah, the radon bath craze didn't last too long.
Okay. So what are like the main risks?
I think everyone knows about lung cancer,
Yeah.
but is there more to it than that?
Well, lung cancer is definitely the most serious risk, especially for smokers.
Right.
The EPA estimates that thousands of lung cancer deaths each year in the U.S. are attributed to radon exposure.
Wow.
Okay.
And there are some studies that suggest a possible connection between radon and leukemia as well, although more research is needed to confirm that link.
Okay, so it's definitely something to be concerned about. But, before we get too doom and gloom, I have to ask, are there any good uses for radon today?
Well, it might surprise you, but yes,
Yep.
radon actually has some valuable applications in science.
Okay, so it's not all bad.
Not all bad. For instance, it's a very useful tool in hydrology.
Hydrology.
Hydrology, that's the study of water.
Oh, yeah.
So because radon is a gas, it moves very easily through cracks and pores in rocks and soil,
Okay.
which allows scientists to use it as a tracer to track the movement of groundwater.
Oh, so like They put it in the water and then can see where the water goes.
Yeah, it's like following a tiny, invisible radioactive breadcrumb trail.
Okay, that's really cool.
And here's where it gets even more interesting. Some researchers are exploring radon's potential for, wait for it, earthquake prediction.
Earthquake prediction. Wow. I did not see that coming. How does that even work?
The idea is that the stress and strain on rocks before an earthquake could actually release radon gas
Okay.
from deep within the earth. And by monitoring changes in radon levels, scientists hope to develop an early warning system for earthquakes.
Oh, wow. That would be huge.
Yeah, it has the potential to be revolutionary, but it's important to note that the research is still in its early stages.
Right.
There have been some encouraging studies that showed spikes in radon levels before certain earthquakes, but there have also been cases where radon levels didn't change or they changed for other reasons entirely.
Okay, so it's still kind of a mystery, but a really cool mystery.
It's a complex puzzle that scientists are still trying to solve.
Right. Okay. Well, I think that's a great place to wrap up part 1 of our radon deep dive.
I agree.
We'll be back in a moment to continue our exploration of this fascinating element.
Sounds good.
Welcome back. Right before the break, we were talking about how radon could be used to track groundwater and maybe even predict earthquakes.
Yeah, it's amazing how something that can be so harmful can also be used in these, really cool ways.
Totally. It really shows how complex elements can be
Yeah.
and how much our understanding of them can change over time.
Absolutely. Radon's story is a perfect example of that.
Okay, so let's dive into some of those fascinating properties of radon that you mentioned earlier. One thing that really jumped out at me in the sources was just how many different isotopes of radon there are.
Ah, yes, the isotopes.
So can you remind us what isotopes are?
Sure. So isotopes are basically different versions of the same element. They have the same number of protons, which is what defines an element, but a different number of neutrons.
Uh-huh.
And that means they have different atomic masses.
Got it.
Some isotopes are stable, while others are radioactive, meaning they decay over time and release radiation.
Right, like
Yeah.
the different flavors of radon. So how many radon isotopes are there?
Well, there are 39 known radioactive radon isotopes.
39.
39. But
Yeah.
don't worry, only a handful occur naturally.
Okay, that's good to know.
And the one we're usually most concerned about when we talk about radon risks is radon-222.
Radon-222.
It's the most stable of the radon isotopes with a half-life of about 3.8 days.
Half-life. Now, there's a term I haven't heard in a while.
Oh, yeah.
Can you refresh my memory on what that means?
Of course. So the half-life is basically the time it takes for half of the radioactive atoms in a sample to decay.
Okay.
So for radon-222, if you start with, say, 100 atoms, after 3.8 days, you'll have about 50 left.
Uh-huh.
After another 3.8 days, you'll be down to about 25, and so on.
Got it. Okay, so some isotopes decay super quickly and some take a really long time. What about those isotopes with, super short half-lives? Do they pose any risk?
Not really. I mean, the ones with half-lives measured in seconds or milliseconds decay almost instantly. So they don't stick around long enough to cause any problems. It's those longer-lived isotopes like radon-222 that we need to pay attention to.
So it's mostly radon-222 that's contributing to those health risks we talked about earlier.
Exactly. It's the one that tends to build up in homes and can be the biggest threat to our health.
Right.
But speaking of radon-222, did you know that it actually plays a role in something called radioactive dating?
Radioactive dating.
Oh, yeah.
Doesn't that have something to do with figuring out how old ancient artifacts are?
That's right. It's a technique used in archaeology and geology to estimate the age of materials, and it relies on the predictable decay of radioactive isotopes.
Cool. But how does radon fit into all of this?
Well, remember we talked about radon-222 being part of that uranium-238 decay chain?
Yeah.
Well, that chain ultimately ends with a stable isotope called lead-206.
Oh.
By measuring the ratio of uranium-238 to lead-206 in a sample, scientists can figure out how long that decay process has been going on, which tells them how old the sample is. Oh, wow. So they're basically using the radioactive decay of radon as a clock to look back in time.
Exactly.
That is so cool.
And it's not just radon. Other radioactive isotopes like carbon-14 are used for dating too.
Right.
Each isotope has its own unique half-life, which makes it suitable for dating different types of materials and timescales.
This deep dive is really making me appreciate just how complex radon is. It's amazing how it can be both a potential health hazard and this valuable tool for scientific exploration.
I know, it really shows how interconnected science is.
Yeah.
And how powerful it can be to understand even the basic properties of matter.
Speaking of those basic properties, the sources you provided mention that radon is a very dense gas.
That's right.
Is that right?
At room temperature, it's actually one of the densest gases, about 8 times denser than the air we breathe.
Wow, 8 times denser. I have to admit, I'm having trouble picturing that. What would that look like if we could actually see radon? Well, if you could see it, you might imagine it as this thick layer kind of settling close to the ground, especially in those confined spaces.
That makes sense, like a heavy, invisible blanket.
Yeah, exactly.
But wait, didn't the sources also say something about radon glowing?
They did. Radon actually gives off this really cool radioluminescence when it's cooled down to super low temperatures.
Radioluminescence.
As the temperature drops, the color of the glow changes from yellow to this beautiful orange-red.
So this invisible, potentially harmful gas can turn into this glowing beacon of light in the right conditions.
It's pretty amazing.
It is. It's a good reminder that even things that seem dangerous or boring can be beautiful and full of wonder. But let's bring it back down to earth for a second, talk about what people can do if they're worried about radon in their homes.
Right. Good point.
What are the first steps someone should take if they think they might have a radon problem?
Well, the most important thing is to get your home tested. There are DIY radon test kits available, or you can hire a qualified radon professional to do it for you.
Okay.
It's a pretty simple process, and it can give you some real peace of mind.
And what if the test shows that there are high radon levels? What happens then?
Well, first, don't panic.
Okay, good to know.
There are some really effective techniques that can be used to reduce radon levels in your home.
Oh, good.
One common method is called sub-slab depressurization.
Subslab depressurization.
Yeah, it sounds a bit intimidating, but it's actually pretty straightforward.
Okay.
Basically, a system of pipes and a fan are installed to pull the radon gas from beneath the house and vent it safely outside.
So you're basically sucking the radon out from under the house before you can get inside.
Exactly.
That's smart. Are there any other ways to deal with radon?
Yeah, there are a few other methods.
Yeah.
Things like sealing cracks and gaps in the foundation, improving ventilation, and sometimes even installing a radon barrier during construction.
Okay, cool. It's good to know there are solutions. What about new construction? Are there ways to build homes that are radon resistant right from the start?
Absolutely. Radon-resistant construction techniques are becoming more and more common,
Oh, that's great.
especially in areas that are known to have high radon levels.
Makes sense.
These techniques involve things like using gas-permeable layers under the foundation slab, sealing up any cracks and openings, and putting in a vent system that can be used if needed.
Okay.
And a lot of places now require these radon-resistant features in their building codes.
Oh, wow. That's great. It seems like we're making a lot of progress in understanding and dealing with radon.
Definitely.
It's also just incredible to think about all the ways it's being used in science.
I know, it's wild.
It really highlights how amazing science can be and how even a simple element like radon can have such a rich and complex story.
I agree. It's been a fascinating journey.
It has. We're ready to dive into the final part of our radon exploration. We'll be back after a short break. Just kidding. We're going straight into the final part. All right, so we're back and ready to wrap up our radon deep dive. We've covered a lot of ground, from the basics of radon to, its potential role in earthquake prediction, its use in hydrology.
It's pretty remarkable how much there is to learn about this element, even though most people only associate it with, basements.
Yeah, right. Before we wrap things up, I wanted to circle back to something we talked about a little bit earlier, radon's density. You said it was one of the densest gases, right?
Yes, that's right. At room temperature, radon is about 8 times denser than air.
8 times.
8 times. If you can imagine like a balloon filled with radon, it would just sink right to the floor.
Oh, wow. Yeah. I guess that's why it's always found in like basements and those lower levels of buildings.
Exactly. Its density plays a big part in why it tends to collect in those enclosed spaces.
Right. So if we could actually see radon, would it be like, I don't know, like a thick fog hanging low to the ground?
Yeah, I think that's a pretty good way to visualize it. Of course, the fact that it's colorless, odorless, and tasteless makes it even more important to test for, using those radon test kits.
Right. Yeah, exactly.
Uh,
Okay, so before we sign off from the world of radon, I just wanted to touch on that radioactive dating thing again, because it's so cool how scientists can use this element to, like, look back in time.
It really is a fascinating application. So remember we talked about radon-222 being part of the uranium-238 decay chain,
Yeah.
and how that chain eventually leads to a stable isotope, lead-206. Scientists can actually measure that ratio of uranium-238 to lead-206.
Mm-hmm.
And they use that as like a clock to tell them how long the decay process has been happening, and that tells them the age of the sample.
So the more lead there is, the older the sample is.
Basically, yes. It's like looking at an hourglass. The more sand there is at the bottom, the longer the time has passed.
That is so cool. So we can use this, like, invisible radioactive gas to figure out things about the past.
It's pretty incredible what science can do.
Yeah, definitely. Well, I think we've really explored the world of radon. We talked about its origins, its properties, the risks, even some really cool applications in science. What are some like key takeaways you hope people listening will remember?
I think the most important thing is awareness.
Okay.
Radon is a real threat, but it's often an invisible one. So testing your home, especially if you have a basement, that's crucial. And if the levels are high, there are really effective ways to fix it. So just knowing about radon, that's a big step.
Yeah, absolutely. And on the the brighter side, it's been so cool to learn about how radon is used in science, from hydrology to earthquake prediction to, figuring out stuff about the past.
It really shows that even in the most unexpected places, there's beauty, there's wonder, and there's potential for incredible scientific discovery.
I love that. Well, thank you so much for joining me on this radon deep dive.
It's been a pleasure.
And to all of you listening, stay curious, stay safe, and keep exploring the fascinating world around us.